Okay, so as we look at these, to convert to binary, first thing we really need to do is list out the place values. So for binary, we have the 1s, the 2s, the 4s, the 8s, 16s, 32nds, 64, 128. Now 128 is bigger than any of our numbers, so we know we've gone far enough. First question, or first checkpoint. Any questions on where those numbers came from? You're just starting out with 1, and always start out with 1 in the first digit. And since this is binary, it's base 2, you multiply by 2 every step you go to the left. Now, what's the largest one of those we can get out of 99? 64. So we can get a 64 out. So we subtract 64, and we are left with 35. Can we get the next digits of 32? Can we get that out? Yes, so we put a 1 there, we subtract 32. Left with 3. Can we get a 16? No. Can we get an 8? No. Can we get a 4? No. Can we get a 2? Yes, we can. We subtract a 2 and we got 1 left. We can get a 1. So 99 is 110011 in binary. 126. Can't get a 128, well, we can get a 64. Leaves us with 62. Put a 1 there. Can we get a 32? Yes. 30, we put a 1 there. Can we get a 16? Yes, put a 1 there. Subtract 16, we're at 14. Can we get an 8? Yes, subtract 8, we're at 6. Can we get a 4? Yes, subtract 4, we're at 2. Can we get a 2? Subtract 2, we're at 0. We cannot get a 1. So 126 is 1111110. Make sense? 17. Well, we can get a 16 out of there, right? That's 1. Cannot get an 8, a 4, a 2, but we can get a 1. So 17 is 10001. Questions so far? Convert to hexadecimal. For hexadecimal, our place values. We have 1s, 16s, 256s, 4096. That's high enough for any of those. $39.72, we can get a 256. How many times can we get 256 out of there? About right. 15 will come out. So 15 times 256 is 3840. So it's 132 left. How do I put 15 over the 256? F is 15. You got it. Now, next 16. How many times does 16 come out of 132? 8 times 16 is 1. Was it? 128. Very good. So I put an 8 in there for 16. We subtract, we have 4 left. That goes in our 1. So 3,972 is F84 in hexadecimal. $938. We can get 256 out of that 3 times. 768, right? So put a 3 there. Subtract, we've got 0, 7, 170 left. Does that look right? How many times can we get 60 out of 170? Or 16 out of 170, I should say. 10 would be 160. 10, of course, is the letter A. Leaves us with 10 again. So there would be 10 ones or another A. So 939 is 3AA in hexadecimal. Okay, then. Octal. We start out with 1s, 8s, 64, 256, no, not 256, 512, and 4096. So obviously we don't need any of those bigger ones. 512 goes into that once. 201 left over, so put 1 in the 512. 64 goes into the remaining 201 3 times. 64 times 3 is 192. So that's a 3 there. We subtract, we've got 9 left, right? So we can get 8 out of there once. Subtract 8, we've got 1 left. So 713 is 1311 in octal. Anybody have all 5 of those right? Or all 6 of those right? Sure did? Cool. Now, let's take a look. At the end of class yesterday, we mentioned that the reason we care about octal at all and hexadecimal is because there's a very quick conversion from binary to octal and hexadecimal. One hexadecimal digit is equivalent to 4 binary digits. If we count them out, 4 zeros is, of course, just 0. 0, 0, 0, 1, that's just 1, right? 0, 0, 1, 0, that's 2. 0, 0, 1, 1, that's 3. And we can count up from there. 0, 1, 0, 0 is 4. 0, 1, 0, 1 is 5. 0, 1, 1, 0 is 6. 0, 1, 1, 1 is 7. 1, 0, 0, 0 is 8. 1, 0, 0, 1 is 9. 1, 0, 1, 0 is 10. 1, 0, 1, 1 is 11. 1, 1, 0, 0 is 12. 1, 1, 0, 1 is 13. 1, 1, 1, 0 is 14. And 1, 1, 1, 1 is 15. Also remember that in octal, 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So coming up here, we start at the end of the number and we work backwards. We're going to go 4 digits. So 1, 2, 3, 4. We're going to cut it off there. Then we'll go the rest. 0, 0, 1, 1 is equivalent to what in octal or in hexadecimal? 0, 0, 1, 1 is 3. So that's 3. If I treat that as 0, 1, 1, 0, what's that equivalent to? 6. So we can just write that as 63 in hexadecimal. Does that make sense at all? A little bit? Clear as mud? So this one, we go 1, 2, 3, 4. 1, 2, 3, oh, we're out of digits. Put our 0 in there. 1, 1, 1, 0 is 1, 1, 1, 0 is 14, isn't it? 14, of course, is E in hex, right? One 110 is 14, which is the digit E. Now I can put the 0 in front of it. 0 1 1 1 is 7, right? So 7E in hexadecimal is equivalent to 1111110 binary. You look confused, Jordan. No? Oh, to get the chart? Here, let's do this. Number 7. Oh, gotcha. This chart? Here, I'll pause there for you. Let's do this. We'll leave it where we've got that chart in sight, and we'll do some conversions. So I'm just going to give you a binary number. And let's convert this thing. So we're going to start at the end, right here. Go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Put a 0 there to make it 4. So 1, 1, 1, 0 is 14, which is E. 0, 0, 1, 1 is 3. 0, 1, 0, 1 is 5. So that converts to 5, 3E. I'm going to have you guys convert one. There. Convert that one into hexadecimal. I'll pause for you. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Add a 0 to make it 4. 1, 1, 1, 0. E. 1, 1, 0, 1. D. 0, 1, 0, 1. 5 and 0, 1, 1, 1. So 7, 5, DE. Okay then. What if we go the other direction? Now, just for the sake of keeping this where we can see it, I'm going to put it right here. F3D8. What's 8? What's D? 1101. What's 3? And F? So I just converted hexadecimal into binary. It's really that quick. Really, the main use of hexadecimal, like I said, is an abbreviation for binary numbers. This here is 16 digits. I can write it in 4 in hexadecimal. Octal. 2 to what power equals 8? 3. So because of that, octal correlates to binary as 3 digits to 1. So if I want to convert binary into octal, of course, now I'm only using this section of this, right? And I can eliminate this 0 at the beginning. I only go 3 digits at a time. So again, I start at the end of the number. I go 1, 2, 3, 1, 2, 3, 1, 2, 3. 001, of course, is 1. 111 is 7, and 110 is 6. So 671 in octal is 110111001 binary. So convert that one there into octal. So 3 digits. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1101 is 5. 011. 3011 is also 3. 001 is 1. So 1335 octal is equivalent to 101101101 binary. What do you think? Neat little conversion? Okay. Base 32, yes. Base 32 gets tricky though because you have to go up to, what do you have to go up to? You have to go up to W. W is for your digits. So anyway, let's look at some basic operations with this stuff. So let's take 2 binary numbers that we're going to add. If I want to add 2 binary numbers, now something to keep in mind, 2 of course is 1, 0, 3 is 1, 1. This is the base 10, and this is the binary equivalent. The reason that's important is we can't have any digits bigger than 1, can we? So here we're okay. 0 plus 1 is 1. What is 1 plus 1? 2. But remember, 2 is really 1, 0. So we keep the 0 and we carry the 1. So I'll pause there. Because 2 is represented as 1, 0 in binary, we keep the last digit, the 0, and we carry the other digit, which is the 1. Now we have 1, 1, 1 is 3, but of course 3 is represented as 1, 1. So we keep the last digit, the 1, and we carry the first digit, the other 1. 1, 0, and 1 make 2. But again, that's 1, 0. Keep the 0, carry the 1. 1, 1, 0 is also 2. Keep the 0, carry the 1. 1, 1, 1 is 3. That again is 1, 1, so we keep the 1 and we carry the 1. What do you think? Now, a process with our whole numbers that we usually don't see. If I have, and I've got to have quite a few numbers to make this work. Let's see, 1, 2, 3, 4, 5, 6, 7. I need at least 4 more. If I add these, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nines. I need one more. I've got 12 nines there. What does that add up to? 108. I'm going to shrink this just a little so we can see it all at once. That adds up to 108. Well, 108, I cannot keep that. So I'm going to keep the 8 here, but to carry, rather, I could carry 10 and put it here, but I can do this. I can carry a 0 there and the 1 there. That's carrying the 10. I can actually go more than one digit over when I carry. So the 0 combines into this column and the 1 is into that next column. Now the reason I show you that, we don't see that very often. It's not very often that we add enough numbers that we're going to have more than 100 in a single digit. But when we have 3 digits like 108, we're going to keep the 8 carrying the 1 and 0. Like I said, we could just carry the 10 all into this place value, but it's easiest if we carry it like this. The reason I show you that is because it does happen quite a bit with binary. I'm going to add these here. Now again, 2 is 1, 0, 3 is 1, 1. 4, however, is 1, 0, 0. 1, 0, and 1 makes 2, so that means I have to do what? 0, carry the 1. 1, 1, 1, 1 is 4. So I'm going to keep the 0. I'm going to carry the 10. I'm going to carry a 0 here and a 1 there. 0, 1, 1, 1 is 3. That is 1, 1. So I keep the 1 and I carry another 1. Notice I've got 2 carried digits in the same column. That's fine. So I've got 1 and 1 is 2, 3, 4. So I'm going to keep a 0, carry a 0 and a 1. 0, 1, 0, 0, that's just a 1. 1, 0, 1, 1 is a 3, so that's 1, carry the 1. That's a 4 again, so that's 0, carry the 0 and the 1. What do you think? Not pretty, but not horrible, right? Doing okay there, Jordan? You got that what the heck look on your face? Okay. What about adding with hexadecimal? Well, the first thing we need to do is convert them to their numerical value. At least the first thing I do is convert them to their numerical value. You don't have to. F is 15, A is 10, C is 12, D is 13, A is 10, B is 11. Deb? So now I've got 12 plus 11, which is 23. 23 is bigger than 16, isn't it? So I'm going to carry my 1 here. I subtract 16. What's left over there? 7. That's a 7 left there. 1 and 8 is 9. Plus 10 is 19. Again, that's bigger than 16. Carry my 1. If I take away 16, what's left? 3. Good. 1 and 10 is 11. Plus 13 is 24. Bigger than 16, so I carry my 1 and I take away 16 to leave me with 8. 1 and 15 is 16. plus 7 is 23. I'm going to carry my 1. Take away 16 is 7 again, and then I bring down that 1. I really shouldn't put a comma in there. So FA8C plus 7DAB in hexadecimal is 17837, still in hexadecimal. What do you think? The key is when you carry there, you're carrying a 16, so you got to subtract 16 from what's there to see what's left. I'm going to have you guys try a couple. Do that one. And just for Jordan, that one. You ready? Sure? Okay. So we've got 1, 1, 1, which is 3. So that's 1, carry the 1. 1, 1, 1 is 3 again. That's 1, carry the 1. 1, 1, 1, 1, 1 is 4. So that's 0, carry the 0 in the 1. 0, 1, 0, 1 is 2. That's 0, carry the 1. 1, 1, 0, 1 is 3. That's 1, carry the 1. And that's 4 again. That's 0, carry the 0 in the 1. So we get 1, 0, 0, 1, 0, 0, 1, 1. Everybody had that one right? Almost. Okay, then Jordan's problem. B is 11, A is 10, D is 13, F is 15, A is 10, C is 12, E is 14. We add here, we got 27, which is bigger than 16, so we carry the 1. Take away 16 is 11, which is B. 1, 10, and 12 make 23. Bigger than 16, carry the 1. Take away 16 leaves us with 7. 1, 11, and 10 is 22. Bigger than 16, so we carry the 1. Subtract 16 gives us 6. 1, 3, and 15 is 19. Bigger than 16, so we carry the 1. Leaves us with 3, and we bring down the 1. 1, 3, 6, 7, B. Yes, because 16 is your base. Because if we have like 79 plus 38, we get 17 here. Well, the reason we have 7 left is that 1 we're carrying, we're subtracting 10 to leave us with 7 because it's a base 10 system. Let's have some real fun. This is base 10. Let's convert that to base 2. How do we put a decimal in it? That's a very good question, Jordan. What do we do with the decimal? This is the 1s, 2s, 4s, 8s, 16s, 32s, and 64s, and so on. Going this way, though, remember this is the 1/2, the 1/4, the 1/8. So 1/2 is 0.5, 1/4 is 0.25, 1/8 is 0.125, right? Can't get a 64 out of it, but we can get a 32, so we put a 1 there. We subtract 32, leaves us with 27.375. Can we get a 16 out of there? Yes. Subtract 16, we've got 11.375. Can we get an 8 out of there? Yep. Subtract 8, we've got 3.375. Get a 4? No. 2? Yes. Subtract 2, 1.375. Can we get a 1? Yep. Subtract 1, we've got 0.375. Can we get a 0.5 out of there? No. 0.25. Yes. Subtract 0.25, we've got 0.125. Can we get a 0.125 out of there? Yeah, that's it. How about 59.375 base 10 going into hex? Where our place values there, 1s, 16s, and 256s. Going this way, the first one's going to be 1/16, 1/256. Well, 1/16 is 0.0625. So if we start out with that 59, can we get a 16 out of there? Yeah, 16 times 3 is 48. That's going to leave us 11.375. So we can get 3 16s. Ones, we can get 11 of them out of there, can't we? So that's going to be a B. Leaves us with 0.375. How many 0.0625s can I get out of that? 6. So it's 3B.6. What do you think? Good stuff? In the packet you have page 503 to 504. These are converting binary to decimal, decimal to binary. We have to do 1 through 41, the odds. Again, you can skip around. On page 507, we didn't cover subtraction, but I kind of want to see what you can do with it. So let's do 1 through, let's go 29. The odds there. On page 511, we're going to look at 1 through 32 there. Actually, should we go 1 through 31, the odds? Page 515. We'll go 1 through 45, the odds. And finally, page 517 through 518. 1 through 39, the odds. Obviously, I don't want you to do all of those problems by tomorrow, but again, do some in each section. Make sure you got it down. The subtraction, since we've got a few minutes here, let's look at the binary subtraction, just for fun. Well, we're having a blast, aren't we? If we go to subtract this, here I cannot do 0 minus 1, can I? So I have to borrow from this. This becomes a 0. What's this become? A 2. Because each place value is a 2. So when you borrow from one, you borrow a 2. Okay, think of it this way. If this were decimal numbers, like 53 minus 28, when I borrow from this, this becomes a 4. What I borrowed is a 10. So 3 plus 10 is 13. That's why it becomes a 13. Same thing here. 2 plus 0 is a 2. So 2 minus 1 is 1. 0 minus 1 can't be done. Can't borrow there, so I borrow here. This is a 0. This becomes a 2, so now I borrow this as a 1, and this becomes a 2. 2 minus 1 is 1. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 1 is 0. So that subtracts 3, just 1, 1. If I were to do this with hex, we'll take a little bit of time if we have to tomorrow to go over it. I'm not going to put subtraction on your test, just so you know. It really comes down to how well do you really understand what you're doing with decimal numbers, or are you just repeating a process? That's one of the reasons why I spend time on this. It makes you think about what's really going on with the decimal numbers. So like this. F is 15, A is 10, C is 12, E is 14. B is 11, D is 13. So I go to subtract. Well, 14 minus 9 is easy enough. That's just 5. 12 minus 13 can't be done, so I'm going to borrow from the A. That becomes a 9. I add 16 to that. 12 plus 16 is now 28. 28 minus 13 is 15, which is F. 9 minus 11 can't be done, so I borrow from the F. Technically, it becomes an E, but we're going to label it as a 14, right? And this now becomes 25. 25 minus 11 is 14, which is E. 14 minus 3 is 11, which is B. BEF5. That's why I wanted to show you that example instead of doing more binaries. Once you see that it's what you're borrowing is the actual base of the number system each time. Okay, like I said, skip around, do some of each of those. Tomorrow is your test, but we will have like 10 or 15 minutes of being in class to answer questions because I plan on hitting Woods with a quiz to keep them busy for a while. I think you guys have suffered more than